Hi guys, I wanted to work a conical pendulum problem for you and answer a few questions and derive some relationships. So let's start with a problem. So let's say we have a conical pendulum here, just a mass attached to a string moving around in a cone shape, but what that does is map out a horizontal circle for us. So the mass is going to travel this horizontal circle here. And we'll let the angle here be 15 degrees. And we will let the mass be 10 kilograms. So if we think about the forces that act on our mass to keep the object moving in a circle, we have gravity, Fg, equals mg, so that is 98 newtons. We have tension here. So there are two ways to come up with a general equation, and I'm going to do a way that's a little bit more straightforward, maybe a little faster, and we'll go from there, and I may show you the other way as well in a different video. But I know, guys, that F net is the sum of the forces. So if I add tension and gravity, I should get the net force, which is, in this case, is the force that moves the object in a circle. So we have tension, we have Fg, which is equal to mg, and those two forces sum to give me the net force. And since the object is rotating in a circle, I will call that the centripetal force, Fc. And for the sake of simplicity, I will let Fc be equal to mv squared over r, because I'd like to find velocity first. So I know the angle here. I'm going to call it theta for now, but it's 15 degrees. I want to derive a general relationship for you, and then we will get to specifics with numbers. So if I look at my triangle, I have the opposite side, for which I have an expression for. I have the adjacent side, for which I have an expression for. And I have an angle. The trig function that relates those two is tangent. So I can say that tangent of theta is equal to Fc divided by Fg. If we plug in our expression, we get tangent of theta is mv squared over r divided by mg here. Our mass will drop out. So our general expression is tangent of theta is v squared over rg. This is a good equation to remember, and we can rearrange to find needed quantities. Now, if I go back to my problem, and let's decide on a radius here. Let's say that the radius is 0.5 meters. Let's find v. So part A, find v. So going to our equation that we just derived, I will let v squared over rg be tangent of theta, rearrange. So v is going to be the square root of rg tan of theta. So that gives me 0.5 times 9.8 times the tangent of 15 degrees. Take the square root of that. And that gives us 1.14 meters per second. Right. From there, I now know v, So I can get the value for centripetal force. What I'd like to know for part B is what tension is equal to. So for part B, find tension. So looking at our triangle, here is tension. Here is Fc, which is mv squared divided by r. Let's go ahead and get values. So our mass is 10 kilograms, and our speed is 1.14 meters per second. So we get a force of 25.9 newtons here, and our other force of gravity, that is going to be 98 newtons. This is a right triangle. So to find tension, all we need to do is Pythagorean theorem. So tension would be the square root of Fg squared plus Fc squared. So that is the square root of 98 squared plus 25.9 squared. Giving us 101.36 newtons for tension. And lastly, for part C, I would like to find the period. Recall, guys, the period is the time for one revolution. And I have a relationship here between velocity and the period. So if I think about the circular path that the object is going to rotate through, if the object starts at this point here, rotates all the way around one revolution, the distance that it's traveled is the circumference, which is 2 pi r. And in that time, which is one revolution, we call that the period, which is capital T. So to solve for that, we get 2 pi r divided by v. So that is 2 pi times 0.5 divided by 1.14. Which gives us 2.75 seconds. I hope this is helpful, guys. Thanks and have a great day.